wanted to take a moment to discuss the amount of data it takes to train a machine. If we compare the amount of data it takes on a machine to train compared to the amount of data it would take to teach a child, there's kind of this striking difference. So if we take a character, say the Hulk, we could probably teach a child with one image because there is this one defining characteristic, which is the amount of green, say in a picture of the Hulk. So a child will almost inertly or almost instinctively pick up on this feature. It's very defining, whereas a machine will not pick up on this feature. Say if we just feed a model like the Inception model that we've discussed a little bit in some past videos. If we just take a model like that and we just feed a bunch of images into it, it won't instinctively say, okay, green means it's probably Hulk. And it gets a little more cloudy with characters that share some characteristics. So if we go on the color characteristic again, there are characters where they share a lot of colors, say Superman and Spider-Man. Both of these characters have a lot of red and blues, so it becomes a greater challenge to separate these out with such defining characteristics. So let's jump right into the data and see what it actually takes. Hero Vision currently knows 10 heroes, superheroes. I guess technically one superheroine. The whole comic book hero thing is a bit sexist. There's definitely way more dudes than there are women. So if you feel like submitting more images to balance that out, I'm more than happy to fix it. It's just a matter of having that data, and I suppose there's not as many out there, so it will always be imbalanced, but we could work towards adding more. It's good to have diversity. We do have a lot of diversity in the images we actually have. So we have random art. We also have, this is interesting, we have a guy doing cosplay as Aquaman. Good job. And we also have the same costume presumably being sold on eBay. Now the reason that we have so much data is because I was able to take a shortcut and use the Google API to basically collect images that they've indexed and just download them. So in short, I was almost able to train a machine with another machine because Google is quite good at classifying images. If you dump in some of these images, it will have a decent idea of who they are. It's not quite as specialized as Hero Vision, so if we were to dump in, say, this guy doing cosplay, then it wouldn't be able to accurately say that's Aquaman as well as Hero Vision, because we have a pretty highly specialized system here. And it took about 100 images minimum. I think Thor is one of the smaller ones. 119 files. So I would say around 100 images is what it takes to get about 90% accuracy with the settings I have and the current data I have. This is how much data it takes to train a model such as the one that we used in the Hero Vision project that can classify superheroes. So 100 is the minimum. Each time we add a new character, it's going to throw off the other characters and it's going to change the overall accuracy of the model. So it really depends on what your data looks like. For example, if we had a totally different data set, say we were comparing text or we were comparing something like audio, then the sample size would be different. But in this case, it takes about a minimum of 100 images to get that 90% accuracy that we're able to see on Hero Vision website. That's all I have for you today. I did mention before that I have this small computer. It's a Raspberry Pi with an attached camera. The camera is broken. It's been kind of fiddly, so I'm waiting on new hardware before we can continue on this project. If you have ideas that we could teach a machine about real-world objects using vision, then leave a comment down below. Other than that, thanks for watching.